inclusion of want-of factor modifies the equations for colligative properties as follows. Now relative lowering of vapor pressure is equal to mole fraction of solute, but this is then multiplied by want-of factor. In the denominator, moles of solute is neglected, so we get relative lowering of vapor pressure is equal to moles of solute divided by moles of solvent, and this is multiplied by want-of factor. Then elevation of boiling point is equal to Kb into molality. Kb is molar elevation constant, but the formula gets modified and Kb into m is further multiplied by want-of factor. So all these equations for colligative properties are modified as want-of factor is multiplied on the right hand side of the equation. Now in this table, value of I for several strong electrolytes is given. Now value of I increases as the solution becomes dilute. For example, in case of NaCl, for 0.1 m solution, value of I is 1.87. For 0.01 m solution, the value of I is 1.94. For 0.001 m solution, value of I is 1.97. So as the solution is becoming dilute, value of I is also increasing. And for complete dissociation, means when NaCl is completely dissociated and number of particles becomes 2, the value of I becomes 2. Then KCl, it dissociates to give K plus and Cl minus ion. Value of I increases with dilution as dissociation increases with dilution. And finally, after complete dissociation, total number of particles become 2, so want-of factor is 2. Magnesium sulfate dissociates as magnesium ion and sulfate ion. Then again, value of I for complete dissociation 2. K2SO4 will dissociate into 2 potassium ions and 1 sulfate ion. 2 potassium ions and 1 sulfate ion, so total number of particles is 3. So after complete dissociation, the value of I is 3. Now here is one example. 2 gram of benzoic acid. So weight of solute is 2 gram, is dissolved in 25 gram of benzene. So weight of solvent is 25 gram and weight of solvent in kg will be 25 divided by 1000. Then shows a depression in freezing point equal to 1.62 Kelvin. Value of delta TF is equal to 1.62 Kelvin. Molar depression constant for benzene is, that is value of Kf for benzene is 4.9 Kelvin kg per mole. What is the percentage association? What is the percentage association of acid if it forms dimer in solution? We need to find the percentage association. So first of all, applying the formula, delta TF is equal to Kf into m, where m is molality. Then writing the formula for molality, Kf into weight of solute divided by molecular weight of solute. Molecular weight of benzoic acid is, let it be m. Then in the denominator, weight of solvent in kgs, so 25. To change the weight of solvent in kg, in the numerator, 25 divided by 1000, so in the numerator we have 1000, and so this is moles of solute divided by weight of solvent in kg. So this is the formula for molality. Value of Kf is given as 4.9 and value of delta TF is 1.62. So rearranging this equation, the experimental molecular weight of benzoic acid is 241.98 gram per mole. This is called experimental molecular weight because this molecular weight is obtained from depression in freezing point of the solution when benzoic acid is dissolved in benzene. Now benzoic acid, it forms dimer. So 2 moles of benzoic acid form dimer if X represents degree of association. Now before dimerization, 1 mole of benzoic acid was present, and x moles of benzoic acid forms dimer, so it forms x by 2 moles of benzoic acid. So at equilibrium, remaining benzoic acid will be 1 minus x moles and moles of dimer will be x by 2 moles. So total number of particles present at equilibrium will be remaining benzoic acid plus the dimer. So 1 minus x plus x by 2, this is equal to 1 minus x by 2. This is the total number of particles at equilibrium. Now value of I is normal molar mass divided by abnormal molar mass, and value of I is also equal to number of particles after dissociation or association. So here number of particles after association is 1 minus x by 2 divided by number of particles before dissociation or association. So before dissociation or association, number of particles is 1. Normal molar mass is the one calculated from the formula, and abnormal molar mass is the experimental molar mass. So normal molar mass calculated from formula is 122 gram per mole. Experimental molar mass is 241.98 gram per mole, and this is equal to number of particles after association divided by number of particles before association. So we get the equation 1 minus x by 2 is equal to 122 divided by 241.98. 1 minus x by 2 is also equal to I, and 122 divided by 241.98 is also equal to I. So we can write 1 minus x by 2 is equal to 122 divided by 241.98. Now rearranging this equation, value of x by 2 will be equal to 1 minus 122 divided by 241.98. Solving, value of x will be equal to 0.992. So this is the degree of association. So degree of association of benzoic acid is 0.992, and percentage association of benzoic acid in benzene will be 0.992 into 100, which is equal to 99.2%. Degree of association of benzoic acid in benzene is 0.992, means out of 1 benzoic acid associated is 0.992. So out of 100, the number of molecules of benzoic acid that undergo association is equal to 0.992 by 1 multiplied by 100, that is 99.2%.